Missed an episode of your favorite podcast? Choose from over a decade of content in our archives, not just the latest episode. All free at gcnlive.com.
This is your call to action. Get prepared, America. Economy, survival, energy, disasters. This is USAPrepares.com. Informative radio, educational radio. Interact now by emailing instructor@USAPrepares.com or text at 434-390-7953. Class, please take your seats. Now, your instructor, Vincent Finelli.
Everyone all set, cocked, locked. Here we go. Your dial set correctly to USA Prepares. We're delighted you're with us. And today, we're going to be talking about two things. We're going to be talking about health, hour number one, and we're going to be talking about more miles per gallon. And some of the things that we've done to actually achieve more miles per gallon with Charles in hour number two. So, for those of you new to the class, there are over 200 of us here at USA Prepares, and we are innovators, we're dentists, medical doctors, broadcasters, farmers, programmers, authors, physicists, surgeons, and none of us is capable of holding down a job. And I'm delighted to introduce to you your newest instructor, Stan Haley of GreenwoodHealth.com. Welcome, Stan.
Good morning, Vincent. How are we all doing?
Stan, are you there?
Yep, I'm here. Can you hear me?
I can hear you. Yep. Hey, Stan, thanks so much for joining the faculty of USA Prepares. I'm delighted to have you with us. I want to make a comment, and I'd love to hear some of your thoughts. When I was growing up, I noticed something. I noticed people in poor health, and I noticed that many of them did it to themselves. Here's what I mean by that. I would see auto mechanics that were aged years before their time. They were in an unhealthy environment. They were sanding. They were in the fumes of chemicals for cleaning and things like that. And you'd see coal miners with black lungs, and they would smoke cigarettes. And then you'd see the guys working on drywall, sanding drywall, inhaling without masks or respirators, the drywall dust. And so you'd see, and people in the military today even. You see young guys going in the military, and they are in harm's way. They're saying, "Yeah, it's okay. I'll be a target. You can shoot at me, and I'm signing up for that. And I'll go to a foreign country I've never heard of, don't even know where it is on the map. But yeah, I'll go there and I'll start these fires and burn military equipment and breathe these fumes." And what they're all doing, there's one thing in common, that when they were young, they traded health for money. So they used up their strength, they used up their lungs, they used up their digestive tract, their eyesight, they subjected themselves to concussions and so forth. And then as they got older, they all wanted the same thing. They wanted to take some of that money that they traded their health for to buy their health back. Would you say that's reasonable? That
Not only is that totally reasonable, but if you extrapolate that out to the average family, they're basically doing it to themselves right now with the foods they eat and the chemicals they use around the house. It's absolutely ridiculous what's happening with our so-called food supply and our cleaning systems, for want of a better term, in the house. But let me give you a perfect example of the result of all that abuse over the years. In the United States, right, the average person spends 85% of their total medical costs lifelong within the last 12 months of their life. That's ridiculous.
Yeah, 85% in the last 12 months.
Yeah, people people wait until they get sick to try and fix what's made them sick. They don't make the correct lifestyle choices to, eliminate the problem from ever happening.
I had a chance to talk with a very senior medical doctor, a guy in a white coat. And he works at what would be the Mayo Clinic of the Midwest. And I asked him, it's a very prestigious organization, very well-known hospital, known worldwide, top 10, and literally the Mayo Clinic of the Midwest. And I said, how do you feel about mineral supplements? And I got the same answer I always get. Well, you get all the minerals you need in the food you eat. It's the same answer I always get. And so I said, okay. Now, why? Because I didn't want to start a war. So I just said, okay. And I let it go. And I have not gotten a different answer from a single medical professional in the last 10 years. Except for Dr. Bill Deagle, except for Dr. Norm Shealy, and I'm talking about doctors, and Dr. Howard Shane. Okay, so, and Dr. M.L. Shane. I mean, other than people who are associated with USA Prepares in the medical, that happen to be in the medical field as well, I have not got, and Dr. Joel Wallach, of course, I have not gotten an answer that was different. Well, from you get all the supplements you need in the food you eat. And I can't believe it.
Well, part of that's a result of the training they go through. They go to med school for 4 years, and then they do postgrad studies and whatever. And I saw something, 6 months ago, that I found amazing. Apparently, during that training period to become doctors, they do cover nutrition and the importance of nutrition. They cover it for a total of 4 hours.
Mm-hmm. Mm-hmm. Yeah.
Now, that's point one. Point two is quite simply this. The nutritional supplement industry doesn't have the billions of dollars available to lobby the doctors, to advertise to the doctors. The pharmaceutical industry, on the other hand, does continually. Do you realize the United States is one of only 2 countries, and actually it may only be the last country because I think New Zealand has banned it either as of January this year or January next year. But the US is the only developed country in the Western world that permits the direct advertising of pharmaceutical drugs to consumers.
Say that one more time, please. I want to make sure everybody hears you.
The U.S. is the only developed country in the Western world that permits the direct advertising of pharmaceutical drugs to consumers. So in simple English, if you go to Britain, Australia, Japan, you are not going to see ads for the latest, greatest pharmaceutical drug plastered all over your TV screen every 10 minutes.
Wow, can you imagine that? TV without commercials. Wow. How delightful.
Well, let me give you another fact on it, right? And this is an actual fact. The U.S. has approximately 5% of the world's population. Okay? Why on earth do we consume 45% of the world's pharmaceutical drugs and prescription medicines?
I would have to say we're programmed to do that. And it's interesting that you're saying this, Stan Haley, because we are being programmed by commercial advertisements, even in what used to be called magazines. Now magazines are about 50% advertisements, maybe even less than 50% content of what you might want to read as an article. So most of the pages of magazines are covered with advertisements for all kinds of things, especially pharmaceuticals. But it seems to me that what is happening is they are being used, targeting the customer or the patient, to say to the doctor, hey, you know what, I think I should be getting prescription A, B, C, and D because, I've read about that. So it's like a demand pull from the patients asking for these prescriptions. And to just drive that point home, I was in line to register a couple years ago to get a checkup with my doctor, my internist. And there was a guy dressed to the nines, really, really well dressed. So I had, a pressed shirt on, I had my dark blue jeans and my shine combat boots, and I was pretty clean cut compared to most of the patients. And there was this guy who was dressed in a very, very expensive suit, and he had a briefcase, and he was in line. And so I had a couple minutes before I was being called in to ask the questions for registration, and I said, "So you're in the drug industry, right?" He goes, "Yeah." So what he was trying to do is meet with the doctors and push the latest compounds that they were trying to get the doctors to prescribe to their patients. And that's how it works.
Oh, yeah.
And doctors aren't doctors bribed with little gifts and trinkets and, junkets? Aren't they bribed with those kinds of things in order to push pharmaceuticals?
Yeah, the pharmaceutical has a marketing budget that far exceeds anything any nutritional supplement organizations ever going to be able to afford. But that's due to their costing. If you want a perfect example of just how profitable the pharmaceutical industry is, I'll give you two examples. Example one is there's a U.S. company that came up with a magic pill to cure hepatitis C, right? It works successfully in 98% of the cases, so it's an incredibly good piece of medicine, okay? Now, if you've got hep C, they will put you on a course of these pills. You take one pill a day for 12 weeks. 7 12s is 84. That's 84 pills, okay? Would you like to guess at the cost per pill?
You mean the cost to manufacture or the final price that is paid with insurance plus?
Retail price. You want to pick this up after the break?
Yes, I'd love to. Stan Hale is with us, greenwoodhealth.com, greenwoodhealth.com, and you'll be able to go to USA Prepares, and there'll be a link to contact him. We'll be right back. Stan Hale is with us, CEO of greenwoodhealth.com. Stan, you were talking about Hep C medicine, and we were talking about what is the retail cost of this medicine to cure/treat hepatitis C?
$1,000 per pill. And
we have a course of
84 pills. So you're going to spend $84,000 in this country to use that product. Now, let's look at the fact that this company also licensed that product for sale in India. And there are Indian pharmaceutical companies manufacturing the pill, paying a royalty back to the American company, obviously, and then retailing that pill to Indian consumers. You can easily check all this out by Googling it. The retail cost of that pill in India is $4.90. That's the difference.
Stan, during the commercial break, I did a search, and I typed in the following words: cost of Hep C meds. Cost of Hep C meds. And the result I got was this particular company priced the treatment at $1,000 per pill, making the total cost of the treatment $84,000. Exactly what you said.
Yep. It is absolutely unbelievable. Let me give you another example. I assume you've heard of CBD oil, cannabinoid oil.
Well, yes, I have. And as a matter of fact, I was talking to a senior medical doctor, and I mentioned that yesterday, and I just got some eyebrows raised. No comment. Not well, we don't think that's any good. Not, it works great. Not, we have patients who are doing it, and we're looking forward to success. No comment whatsoever. Nothing. And okay, and I'm taking it. I have CBD oil right here from your company. Okay, and so I take it, and I think that it's working. But let me say this: I have asked. I hope I don't derail this broadcast. I have asked my pulmonologist about CBD oil, carbon-60, colloidal and ionic silver, iodine, colostrum, okay, and other supplements, vitamins, minerals. And what I get is, well, I'll tell you what I got. I got fired. I got fired by my doctor. They finally admitted. They said that I was not compliant. I wasn't following directions. I wasn't doing what I was told. They made up all kinds of reasons why Vinny got fired by his doctor. And yeah, it happens. But the real reason they finally admitted to me was I asked too many questions. And what are those questions? What are your thoughts on CBD oil? What are your thoughts on carbon-60? What are your thoughts on colloidal or ionic silver? What are your thoughts on serapeptase? What are your thoughts on iodine? Now, I don't get into a debate because I only have 7 minutes. It's just quick question, quick answer. If they say, we don't, it's not part of the American Medical Association's protocols. I mean, it stops right there. Okay, they don't know. They don't know. So I can tell you that is what happened, and I'm not willing to just limit my education to what I learned in 7 minutes from a doctor's visit. I want to know more.
Yeah.
Please continue.
CBD. Unless you've been living under a rock for the last 5 years, you're well aware of the magical results that tens of thousands of people all over the country are getting by using CBD. The official U.S. government stance on it is that anything coming from cannabis has absolutely no medical applications whatsoever, which I think is a little funny because I assume you've heard of a little U.S. government department called the Department of Health and Human Services.
Yes, I have.
You might want to Google and find out just how many patents they hold for the use of CBD for treating different diseases.
Okay, let's talk about that a little more when we come back. GreenwoodHealth.com. GreenwoodHealth.com. Class, if you'd like a link to Greenwood Health, you can go to usapreparedness.com, click on the Instructors tab, and you'll see Stan Haley, and there's a link right there. Take you right to the website. Stan, so I did exactly what you said. I did a search on HHS, Health and Human Services. I've been inside that building in Washington, D.C., the Hubert H. Humphrey building. And back in the 70s, when I was doing some system design for the government, computer systems design. And so I've been in this huge, very expensive building. And so I looked up HHS CBD patents. Patent number 6630507 shows up. And the DenverPost.com says, why the government holds a patent on cannabis plant compounds. And it goes on to say that the Department of Health and Human Services was granted this patent, 6630507, and it covering the potential use of non-psychoactive cannabinoids to protect the brain from damage or degeneration caused by certain diseases such as cirrhosis. So here they have a patent on this CBD oil or cannabis oil, and yet we're not supposed to use it? Is that what this is all about?
No. Once again, what this is all about is the pharmaceutical industry. There is a British pharmaceutical company that has just completed what are known as phase 3 drug testing through the FDA requirements, right? They have spent $1 billion proving, and this was written up in the New England Journal of Medicine, they actually had a large group of kids that were seizure-prone, where existing seizure medication was not working, right? They put them on a course of CBD oil, and what they achieved was a greater than 50% reduction in seizures for greater than 50% of the kids that were taking it. Now, they are spectacular results. That is also a result that anybody that's been involved with CBD would know has been happening for the last 10 years or so. But here's the kicker. You can buy high-quality CBD oil right now at a price range of between $50 and $150 per bottle, depending on the strength, the active ingredients, and the size of the bottle. Okay? Now, once this pharmaceutical company gets permission to actually put this out as a pharmaceutical drug, it's going to be available on prescription. And here's the kicker. They have not released the actual retail cost of this product yet. However, it is estimated that the costing per bottle will be between $2,500 and $5,000. That is ludicrous.
Wow.
It's all
what do you
about
say?
Profit.
Yeah. And that would be those junkets, those bribes that are ongoing in what Dr. Norman Shealy calls the pharmaca mafia.
Yeah, well, don't forget the $300 million a year they spend lobbying Congress. It's absolutely crazy. Look, we do not have a health care system in this country. We have a profit-based business model that is designed to keep people sick. Pharmaceutical drugs are not designed to cure people. They're designed to develop customers. The more customers they've got, the more money they spend, the more profit they make. It's really, really simple. Once you understand that, everything else falls into place. And my company and every other company that produces any sort of nutritional supplements is up against it because we're competing with pharmaceuticals. And we can't say anything. You buy any nutritional supplement in this country, in clear letters on each bottle is this product is not intended to diagnose, treat, cure, or prevent any disease. If, on the other hand, you're watching an ad on TV for a pharmaceutical company, you've got happy people jumping all over the place and whatever, and then at the end of it, they'll give you some of the most common side effects, right? But unless you actually go and read on the fine print on their website, and you'll need a magnifying glass to do so, you're going to miss the 10 or 11 pages of also known side effects.
And many of them include death. Actually, I'd say the funniest one I've seen, although there's nothing funny about it, is there's a particular pharmaceutical drug they stick people on that are going through chemotherapy, which is designed to reduce the amount of nausea and vomiting associated with the chemo. Now, that's a great idea. However, if you go and read the side effects of that, there are 22 side effects listed in order of importance. The first one is may cause nausea and vomiting. Excuse me. Yeah, and I've seen similar results or warnings from medications that are supposed to treat certain maladies, and they cause the exact maladies that they're touting that they can alleviate.
Yeah, but it's a profitable domino effect for the pharmaceutical industry. They put you on a drug which causes a side effect. So they put you on another drug to mitigate the effect of that side effect, which puts you on another side effect, and so on and so on and so on and so on. And you get people on 5, 6, 7, 8 different pharmaceutical drugs.
I just did a search. And I typed in a search engine, average number of prescriptions. And here's what it says. The statistic shows the number of prescriptions per capita, meaning per person, in the United States in 2013 by patient age group.
Yep.
In 2013, patients between 50 and 64 years old had an average number of 19.2 prescriptions per person. 19. How do you manage that? How do you remember to take what, when, and how do you have enough counter space to hold all those prescriptions? And which ones interact negatively with which ones? I got to tell you, that is really complicated and over the top. And it just tells us that we are being bilked and we have to be overprescribed, because back in the 1950s and 60s, hardly anybody had more than one prescription, right?
Yeah, because the foods we were eating were actual foods. We weren't subject to all of the chemicals. And, look, nutritional supplements are exactly what they say they are. They are designed to supplement the nutrition that we're consuming.
Mm-hmm.
And that is critically important, because the human body is a marvelous, marvelous piece of engineering. We can fix most of the problems we develop if we give the body the nutritional tools that it needs to do so. And that's what my company's all about. We don't claim to cure anything, but we have an exceptional range of products that provide nutrition to the body.
Stan, are you a healthcare practitioner or a research scientist?
Nope, not in any way, shape, or form. I've been involved with the nutrition industry since the 1980s. I am definitely not a medical doctor, and I'm not a research scientist per se. What I am extremely good at, with about 30 years' experience, is searching out the best possible ingredients to put them into products and put them there in such a way that they are effective and they'll actually generate results. You familiar with the term fairy dusting?
That was my next question, and yes, I am. And you mentioned that on the phone quite some time ago, and I've been intrigued with that term ever since you mentioned it. Please tell us what fairy dusting is. I think this is going to be a great eye-opener for our class. Fairy dusting.
Fairy dusting is the term that basically involves putting some of one particular ingredient into a product to be able to make what are officially known as structure-function claims through to SHEA, which is the Dietary Supplemental Health and Education Act of 1994. So, in simple English, if you're doing up a batch of ingredients into a product and you've got 1,000 kilos, right, in your batch, you can literally take a pinch of something, sprinkle it over the batch, and put it on the label, because it actually exists in the formulation. Now, the fact that it doesn't exist in any amount to provide any beneficial result is irrelevant. And let me give you a perfect example. There's one company out there that sells a very, very well-known vitamin mineral supplement that they advertise on TV all the time, and it's in magazines. And they're talking about the fact that it contains lycopene. And they list all of the magical results that have been obtained by taking lycopene. And that's all very well and good. The consumer looks at the label and says, oh, great, it's got lycopene in it, it'll do this, this, and this for me. What they don't realize is a very simple fact. Everything they are referencing with regard to lycopene was based on a daily dose in clinical studies of 3 grams per day, okay? If you have a look at their label, it has 3 micrograms, so they have 1/1,000,000th of the amount required. We'll pick it up after the break.
Stan Hill is with us. He's the CEO of GreenwoodHealth.com. You can go to GreenwoodHealth.com, or you can go to USAPrepares.com and click on the Instructors tab, and you'll find a link to Stan Haley. And he's going to be back. Stan, do you want to give out a phone number for those who are interested in contacting Greenwood Health?
Yeah, I'll be more than happy to. 620-665-7900. And if anybody's interested in having a look at our product range, the easiest way to get there is greenwoodhealth.net/USA Prepares. That'll take you straight through. But if any of the listeners want to call in, order products, know more about the products, just tell the girls that answer the phone you're coming from USA Prepares. That work?
That's sure, 620-665-7900. Repeat?
Yep.
620-665-7900. We're talking about fairy dusting, and that is such an important term because we can easily be misled by claims of advertisements and claims on the label. Yeah, please continue that.
Well, let me give you another extreme example of fairy dusting. Within this industry, you're allowed to use what are called proprietary blends. We actually use proprietary blends in some of our formulations, and we use it to protect the integrity of the formulation. In other words, we're not going to tell anybody exactly how much of each ingredient we've got in because we don't want to build a roadmap for somebody that wants to knock our product off. But there is another use for proprietary blends that's not quite so consumer-friendly. Let me give you a ridiculous example. Let's say you've got 6 ingredients in a formulation, and your daily dose is 1 gram out of those 6 ingredients. And 2 of those ingredients cost $10 per kilo wholesale. The other 4 cost $1,000 per kilo wholesale, okay? What you can legally do is ingredient 1, which is worth $10, and ingredient 2, which is worth $10, you could put, for example, 498 milligrams per capsule. That gives you a total of 996 milligrams per capsule. But those 2 ingredients don't have much in the way of structure-function claims attached to them. The other 4 that do, you put in at 1 milligram per capsule. Make sense?
You're talking about 1/1000th of the capsule with the expensive ingredients, and 996 parts of that capsule out of 1,000 are the $10 per kilogram component.
Bingo.
Yeah.
But you got a great label. You got an absolutely great label. And that's how a lot of companies, unfortunately, use proprietary blends. Fairy dusting is absolutely ridiculous. We do not put an ingredient into our products unless it is there in an amount that has been clinically shown to provide the benefit that we're claiming for it.
And when you talk about CBD oil, as we have, which is a hemp oil,
yep.
How do we know as customers what the percentage of actual CBD in the hemp oil that's in the bottle? How do we know what it is, the strength, how can we tell that it's really what we want rather than we'll call it watered down or fairy dusted product?
Well, I can answer that 2 ways. You can't believe any of the so-called certificates of analysis that some companies stick on their websites because it's very easy to get a certificate of analysis for one batch and then change your batch to something that's a lot less. We don't bother sticking the C of A's up. We state on our label how much is in it, and we're not going to lie because if we ever got found out doing so, we'd get put out of business. And, keep it in perspective. We're not a new company. We're 18 years old. We have a AAA plus rating with the Business Bureau. Mm-hmm. And we're going to go to another break, I believe.
Yeah, well, actually, this hour is over, Stan Haley. So what we'll do is you'll be back with us again and again, and let's continue this discussion in detail.
I would love to.
Yeah. Thanks so much for joining us, class. The link is on the website, usaprepares.com. under the Instructors tab, or if you'd like to call, 620-665-7900. And that's Stan Haley. Stan, thanks so much for joining us and becoming an instructor at usaprepares.com. Class will be back with Charles in Ohio talking about automotive engines. Everyone all set, cocked, locked, hour number 2 of USA Prepares. And I'm delighted to be broadcasting with a student who's risen to become an instructor, Charles in Ohio. And this is Automobile Engine Efficiency, part number 2. Welcome, Charles.
Good morning. Glad to hear you.
Well, thanks for sharing your expertise. So, Charles, you have built race engines. You have been on the track, and you know we've compared notes off the air about things that we've tried and things that work. And you know, as I mentioned the last time you were on with us, I was really intrigued by how, you know, I mentioned that I had a 1968 AMX made by American Motors, and it was like the Javelin, but there was a foot cut out of the middle of this particular two-door sports car. Had 2 seats, only 2 seats. It was not a four-seater or a 5-seater. It only had 2 doors. And mine has, and I still have it, has a 390 cubic inch engine, 4-speed, 4-barrel Carter AFB carburetor, positive traction, and I raced it. And you knew, I mean, within just a couple percent, what the elapsed time that I achieved at the quarter mile was, and you knew the trap speed, the speed at which I crossed the finish line, you know, back in the 1970s. Now, I know you weren't there. We've never met, you know, in person, and you haven't seen the vehicle. And so if we could just take a couple minutes and go through how you could possibly know that, that is germane to today's discussion as to how we can improve fuel efficiency, fuel economy, and how we can make our cars go farther on that gallon of gasoline. So the question is, how did you know?
Well, like I say, when we were speaking, I spent quite a lot of time wondering, because I got the same question, a similar question with my friends at a younger age. They told me, well, how fast are you planning on going in that car? And so I sat down and started looking at information to kind of see what others had achieved before me. There are trailblazers like you who beat out a path for people like me who who go out and follow you. And, you know, I mean, it just makes it easier. And that's why I look at the patent office for inventions people already had for fuel mileage. I thought I could make a car go 100 miles per gallon, but I didn't want to reinvent the wheel. I wanted to follow, at least look at what people who said they already achieved it had done. So in quarter mile performance, it's been, there are so many people out there trying so many different things that you still end up with a kind of a standard stair step you do in achieving performance. A basic factory cars, they're very good, but they all have deficiencies, and they're not planning for you to go drag racing them. They just want you to buy them, and and you go from there. So generally, people know and follow the same path, and depending on how serious they are, they end up at the same place. A vehicle is just a weight, and the engine is just a box that horsepower comes out of. And so once you know the weight of the vehicle, and I believe you told me you're ET, and then I extrapolated from there, but although you can do it backwards too. But you know that you draw parallels to other manufacturers, because the cars, like I say, in the muscle car class, cars will range from, you know, they can range all over the place, but generally from like 3,200 pounds to 3,600 pounds. So you know what area you're operating in. So what I did, I went down to the library and I went back to old Road and Track, Car and Driver, and other magazines that tested vehicles back then, and they would do annual roundups and monthly performance evaluations of vehicles, and I ended up with a bunch of quarter-mile times and performance. And back then, they would break it down so that every 20 miles an hour, they would give the ET acceleration. So you'd have it for in between, like going up to 60, so you'd know what the acceleration was up to 60, and then you know what it was. Vehicles that would go 100 or even faster, you'd have that also. Well, it turns out once you start looking at that, regardless of if it's a Mustang or a Camaro, if it's 3,200 pounds with a factory engine, you know what you're dealing with, a V8 or, a small block 350, even 6 cylinders. But you look at the factory, gives you ratings for it, and what the math will give you the performance of the car. See, once a car is established at 3,600 pounds, the thing is, your gear ratio can affect it, but when you're on the drag strip, you've already optimized your gear ratio if you're serious. So people who aren't that, when it comes from the factory generally, unless you're planning on drag racing it, you don't order the trailer towing the low gear ratio you need for performance. But when troubled individuals like you and I get hold of it and we want to go fast, we'll put a performance ratio in it. And so that levels out the playing field. Once you have the gear ratio, once you put the tires on it and you've established you're serious, then across the board, a 3,500-pound Mustang, Camaro, and AMX, which is a little lighter vehicle, they'll have similar performance, and they all have stop marks on the way. One of the things you kept your stock manifold, which, like I say, that gives you even more impressive performance, more impressive work you've done to get there. But a lot of the first things individuals will do to increase horsepower is intake manifold, headers, and a carburetor. That just frees up. Your engine is only an air pump. And most stock engines, they rate them all over the place, and those ratings are pretty accurate. They did change the way they rated horsepower back, I don't know, maybe the 70s, from gross to net, which would include like accessories, like the fan, because as you had said, you had a cutoff for your alternator, and that fan does drag horsepower. I'm sorry, the alternator does drag horsepower, and the same with the fan. Clutch drive fans are a little less problem, but they're a weight on the front of the engine, and they take horsepower to turn, like your alternator, your power steering. And people who are absolutely after every single horsepower they can get, they cut out those accessories, and that's where, like, underdrive pulleys come in that are popular for some performance vehicles. They take less horsepower with a smaller pulley on the damper side.
Yeah, what Charles is talking about is you have a radiator fan on these older vehicles that was driven by a fan belt, usually typically a V belt, shaped like a V, if you will. And that fan would use horsepower. And if you wanted that horsepower to drive the fan, it would not be available to push the car down the drag strip as fast, because you were deducting horsepower for the fan and the alternator and the power steering pump and the air conditioning apparatus, the pulley, you certainly would not want your air conditioning on, because that may take 7 more horsepower away from moving your car down the track quickly. So a lot of things that we looked at. Some people, class, even took off their water pumps on their engines. And this is the cooling system water pump. They would take off the water pump to get to the veins, if you will, and they would make them smaller so that the water pump would pump less water or coolant through the engine. And the logic there was it would take less horsepower to move less coolant through the engine. Now, there's a disadvantage because, heck, you can overheat. But, I mean, people were looking at all kinds of ways of reducing parasitic drag, friction, weight, everything they could even think of. I mean, some guys went so far to reduce the weight of the vehicle, they would take out under the carpeting, if they had carpeting, they would take out the padding, because they could probably pick out another 5 pounds of padding, or maybe more. They would take out every nut, bolt, screw, washer, iota of anything that added weight to the vehicle to make the vehicle lighter, to move faster down the track. Some guys, would wear very, very lightweight clothing. And I don't mean to be graphic here, but some guys went so far as to not wear underwear because, heck, it's like another 10 ounces, right? Charles, you've heard of all that, right?
Oh, exactly. I mean, I'm familiar with most of that. I hadn't heard, I knew about the water pumps, but I didn't know individuals doing it. But it only makes sense because every aspect of the automobile, the manufacturers, things we don't even think of, they look into. And they spend a lot of time and effort, even like the aftermarket. There's a popular modifications to water pumps still now that they sell over the counter. So, all of those, if people are looking for that horse, that extra edge, anywhere they can get it.
And we come back. Let's take a couple minutes and talk about front-wheel drive cars. What happened? Why we have front-wheel drive cars? And it was a technical solution to a fuel consumption issue. Charles is with us. He's in Ohio. We'll be right back. Because most of the vehicles that you see on the road are front-wheel drive. And there's a reason for that. Back in 1973 and 1974, we had the Arab oil embargo, and there was a shortage of gasoline in the United States. And as a result, if someone had a Volkswagen Bug, and I guess they call them Beetles, we used to call them Bugs, Volkswagen Bug, that was more valuable than a brand new Cadillac, because brand new Cadillac wasn't worth much because they got maybe 10 miles per gallon, and you couldn't find fuel for it. You had to wait in lines, gas lines that would go around the block. You wait hours and hours and hours to get a few gallons of gasoline. So people with Cadillacs, brand new Cadillacs, would be glad to trade them for a used, banged up Volkswagen Bug because they got 30 miles to the gallon. They could actually go somewhere in their vehicle as compared to the Cadillac, which became a lawn ornament or a driveway ornament. Well, in order to improve economy and fuel economy, the Chrysler Corporation started experimenting with front-wheel drive cars. And what they did was, originally most cars were rear-wheel drive. So you'd have the engine in the front, you'd have the transmission attached to the engine, you'd have a drive shaft between the engine and the rear end or the differential, and then so you had a lot of running gear, and the gear oil in the differential was very heavy, thick, viscous, and it was hard to turn the gears through, so it consumed energy and horsepower. Well, if you took all that and said, let's combine the differential in the rear and the drive system, and we'll just attach it right to the engine, and we'll run it all in very thin, very slippery automatic transmission fluid, we can save some horsepower and get some fuel economy. And that's what Chrysler Corporation did. But just to let you know, they weren't the first. The first front-wheel drive vehicles, we'll call them horseless carriages, were around 1898 and 1899. And around 1906, they were beginning to appear a little bit more, and even raced in the French Grand Prix in 1906. So front-wheel drive vehicles are not brand new. They've been around for a long time, well over 100 years. And one successful example of a very, very well-built front-wheel drive vehicle was the Cord L29. CORD was the automobile manufacturer. Very prestigious company. Charles, you want to weigh in on front-wheel drive cars and a little more about them and why?
Absolutely. Front-wheel drive vehicles came into favor recently because, just as Vincent has said, the transverse engine with a transaxle is a much more space-efficient, compact. It allows the firewall to be closer toward the front wheels, allowing weight savings in the construction of the car. The driver's compartment, it gives more leg room and headroom than a conventional or longitudinally facing engine, and it does have advantages in those areas. But just personally, from growing up with standard front engine rear drive, I just tend to kind of favor that, which is just kind of stick in the mud that I am. That configuration has advantages in performance and weight distribution. Sometimes it's a little easier to design a performance car for good handling in that configuration than with a front wheel. Although, if somebody's dedicated, just about any problem can be diminished or overcome.
You know, it's interesting as we're discussing this. If you look at that Volkswagen Bug that I was talking about, it had a rear engine, rear transmission, and it was all kind of bundled together in one package. Separate units, separate systems, all bundled together. But it made for a very efficient transmission of power. And Lotus, Lotus, the automobile manufacturer, was a pioneer in racing. I mean, they were really a force to be reckoned with. And I'll mention a little bit about what they did and how they implemented their solutions on the highway. We'll be right back. So Charles in Ohio is with us. In class, our plan is not to teach you or tell you what to do. Our plan is to teach you how to think. And Charles hit the nail right on the head. And he doesn't want to invent the wheel because it's already been invented. So why go through all of the time and effort to invent something that you can just do some research and figure out what other people have done and then say, okay, there's 5 different ways of accomplishing that or skinning this cat, and why don't we take the best approach or maybe combine a couple of the different best approaches and make the single best approach with our twist on it and make it even better than that. So the reason I'm mentioning Lotus, Lotus, as an automobile manufacturer out of England, and they did something really neat. Back in the 1970s, actually the late 60s, they came out with a couple vehicles. One of them was called a Lotus Europa, Europa. And Lotus was a pioneer on the racetrack, Grand Prix type racing. And for the consumer market, they built a car that had a Ford 4-cylinder engine. It was a 1600cc 4-cylinder engine. Now, that engine had a cast iron head, and it was actually out of a Ford Cortina, which was a European vehicle. But that wasn't good enough to just drop that into one of their street cars. What they did was they took the head off, and they installed something kind of new. It was a double overhead cam Hemi head on a standard cylinder block, on a Ford 1600cc block. So now he had a 1.6-liter double overhead cam Hemi engine in the very late 1960s. So you had better combustion, better explosions, more thorough explosions, better efficiency. And then they added to that a better exhaust manifold, more efficient at exhausting the hot gases. They added a better intake system with 2 carburetors, and they installed a small simple high-flow exhaust system, very small, very short, not a lot of internal restriction. Then they stuck that engine in the middle of the car, just behind, it was a two-seater, just behind the seat back was the engine. Now, behind the engine was, and the engine was turned around backwards. And so the engine, well, the front of the engine faced the front of the car. The driving end of the engine attached to a transaxle. But they took the transaxle out of a Renault front-wheel drive vehicle, and they turned it around backwards. So instead of pulling the vehicle with the transaxle in the front of the vehicle, they put it in the back behind the engine. So the rearmost component was the transaxle. They eliminated the drive shaft, so now they had a really lightweight 1,558-pound vehicle with a double overhead cam Hemi 1.6-liter engine in it, and that thing had balanced gas tanks, one on each side of the engine, two 7.5-gallon gas tanks. It was aerodynamic, it had a lightweight fiberglass body, and it was a street-legal race car that got 30 miles to the gallon. What I'm saying is, so Colin Anthony Bruce Chapman, the founder of Lotus, went through design after design and picked the best of the best of the best and figured out how he could use what was available, modify it, and make it work even better. And that's what the rest of our discussion is about today. Charles, did I say that in a way that you think was clear, or do you need to add to that? Did we lose Charles? Okay, so we just lost Charles. He's going to come back. So I'm intimately familiar with this Lotus Europa. I've driven it, I've raced it, and it was a heck of a car. And it was stripped down to be as light as possible, so it would have more horsepower per pound than pretty much anything else that you could find. Charles, I was talking about the Lotus Europa and how Colin Anthony Bruce Chapman, the founder of Lotus, a motor car company, took great ideas from lots of places, tested them on the track, and put those concepts into practice on the street. And he made a street-worthy race car that was blazing fast, and it got 30 miles to the gallon. Do you have any suggestions on how technologies that you have found in your experience can be implemented for those of us listening to our class? What can we do to make our machines run more efficiently, get more miles per gallon?
There are some very simple things you can do to a common automobile to improve efficiency and mileage. And one of the things I like is water injection, but I call it the humidification. I guess it's up in the patent office that way too, both ways, because people do inject water, which is common and has been done for years and years. And humidification, though, it takes the water to vapor, because just like when you're burning gasoline, a carburation system aspirates liquid gasoline into the engine, and some of it reprecipitates or remains liquid back down in the intake manifold between the carburetor base and the valve, and that's undesirable. You want the gasoline as atomized, as complete as possible. You also want your water. Having it going as liquid isn't always as big as an advantage as having it go through the engine as vapor. And one thing I found is looking at people's patents, and I've had so many patents on individuals who have used water injection or vapor injection. The thing is, when you know what you're looking for with that is like 15%, well, even up to 25% improvement in fuel mileage. So if you haven't achieved that once you try humidification, you haven't optimized your system yet. And by optimize, I mean to take full advantage of it with a carbureted vehicle, which is easier. And one thing on we had spoke that General Motors, Ford, Chrysler, John Deere, they all consider their computer and software, the computer you own, but the software they keep. And they really don't have a lot of desire for you to fool around with it, although some people will take care of that for you. And I like more open source stuff, and there are complete fuel injection aftermarket systems you can buy to run a fuel-injected vehicle, but that's another point. But if you know what kind of mileage you're looking for, you have to tune, once you put your humidificate or any fuel improvement system, you have to go back and tune it to work with it. Even if it's an electronic controlled engine, you can get advantages, but tuning the engine gives you the most advantage. So you're, like I say, you're looking for up to 25% improvement in fuel mileage by using humidification. And along with that, you can include other devices that fit on and are fairly simple to do. You can use an auxiliary air device, but what that is you have a base plate of a carburetor. You can bleed air into it, and what this does, this will let you vary the air-fuel ratio slightly by entering more air. You lean the mixture, and it can cause turbulence, which will help keep the fuel suspended and aid in vaporization. See, like I say, if you ever look at dyno pulls for carbureted vehicles and fuel-injected vehicles, you'll see that fuel-injected vehicles do a lot better. Now, it varies. Some manufacturers have their act together really well, and some not so. But commonly, when you look at a fuel injection curve for the same engine, you look at the dyno run on a carburetor, then you look at it on fuel injection, what you usually have is where the horsepower peaks, a carburetor would do better. But in the area where the torque peaks at the lower end, the fuel injection does better. And what's happening is the velocity of the air traveling through the intake system, once it hits a certain velocity, which is at sonic speed, like it's something around 280 feet per second, then the fuel stays in suspension and it actually mixes from the carburetor venturis down to the valve. The fuel stays in suspension with the air, and that's where the torque, the horsepower peaks best with carburation. The air just moves really well. Well, the thing is, down at the bottom end where there's deficiencies, the pressure in the spray unit of a fuel injection suspends the fuel better. And so you'll see the difference between the two. But like I say, humidification and then the simple device, the auxiliary air bleed, which will give you a little bit of tuning, and it allows you to bleed in some more air, and that will improve your mileage. That's the second way. And there's a third thing that's fairly simple, too. They call it a fuel expander, because when you go fuel your car, if you go first thing in the morning, you get slightly more fuel, because the fuel is denser, just like air denser. You have more in a package, more in a cubic foot. More when air is cool, you get more air in a cubic foot. When gasoline is cool, you get more gasoline in a cubic foot. So when you pump, you get more gasoline.
That's a very good point. And so, class, what you want to do is you want to buy gasoline when gasoline is cooler than when it's hot. So if you wait till the warmest part of the day and the gasoline in the tank that you're pumping from at the gas station, their gas tank, is hot, you'll get less fuel than if it's cooler. Absolutely true. We'll be right back. Charles in Ohio is with us. And Charles, I've got a couple quick things I'd like to say. I experimented with water injection. Now, before World War II, we knew in the United States that if you injected water into an internal combustion engine, like in an airplane, that might be in a dogfight or that needed to have more horsepower to take off, we could inject humidification, which is exactly what you're talking about. I experimented with it in the 1970s, early 1970s, And it works. It absolutely works. I wanted to say a couple other quick things, and I'd love to hear your comments. So, class, very simply, a clean air filter will improve your miles per gallon. Okay, one that's restricted, one that's dirty, will cost you miles per gallon. The thinnest oil that is recommended by your automobile manufacturer will probably give you the most miles per gallon. Thicker oil is harder to pump, and it will cost you miles per gallon. If you change the lubricant in your differential to a synthetic lubricant that's approved by your automobile manufacturer, you'll probably pick up a little more economy. If you inflate your tires to a higher pressure, but do not exceed that recommended by the tire manufacturer. That is indicated on the sidewall of your tires. Now, you may have 4 different tires on your vehicle. If you buy them at different times, they may have different maximum pressure ratings. So you have to read them all. Okay, so check that out. And one other thing I want to talk about is the tailgate myth. Now, I was on the internet, and there are people who are saying, "Oh, your tailgate on your pickup truck. No, that doesn't. If you leave it on or off, it doesn't matter. You get the same miles per gallon." Absolute nonsense. You will get more miles per gallon at highway speeds with your tailgate off in almost every circumstance than if you have your tailgate on and in the normal up position. Charles, your comments on any of that?
Absolutely, and those are all things that to get a good start on. Some people interested. All these things we're telling you, they're available. People have done them on the internet and demonstrated them. And one source for information, like you're giving good information, it's the mobile fuel mileage run you used to do way back in the early 60s. For years, Mobile would get together people who wanted to go out and try different methods of improving mileage, and one of them wanted a higher mileage. One of the record holders was it was an Avante, and the guy he took and wrapped and insulated the intake manifold, and he used high pressure in the tires, and he removed the shock absorbers, because those shocks are just like anything else. They get hot from bouncing the road, and they do take energy from the car. And like we were talking about horsepower earlier, one way you can measure it is by your ET, which we were talking about earlier. And when you measure it, you have to subtract the ET from your deceleration. So you take your car up to cruising speed, you throw it in neutral if it's manual, and you measure how long it takes to go from whatever miles an hour to 0. The longer it takes, the less horsepower it takes to move that vehicle, and that's a better vehicle. And that can be affected by things like your alignment, your tire size. There are always factors in there. But back to the gasoline temperature, we're talking about getting dense, cold gas in the morning. When it goes in the engine, you want it at an optimal temperature. And generally, for a common vehicle using common pump gas, it's going to be around 120 degrees. And again, like Vincent said, this is all stuff that can be very, very dangerous. So you need to be familiar with safety. And if you don't think you're capable, you have to be your own safety officer and tell yourself not to do it if you're going to catch yourself on fire. Because I don't know about Vincent, but I've seen a lot of that. And that ain't pleasant at all. And so...
I've avoided... You're absolutely right. I've avoided all those dangerous situations as best I can. And yes, I have seen some vehicles at the track catch on fire. I've seen it. Pushing the limits. It's dangerous to push the limits. But sometimes that's how science is done. I'm not advocating doing things that are dangerous. I'm really not. But I am advocating doing research and learning more, so that maybe, you might want to say, I think those guys might be right about the tires and the air filter and the synthetic differential lubrications and maybe a thinner engine oil according to my manufacturer. Maybe there's some things like that I can do, and maybe take the tailgate off and see if it works. And you're going to find out that it really does. Charles, thank you so much for being with us. Class, above all, honesty and integrity. What happens next is up to you.